In this video, we'll start to explore the differences between public and private IP addresses. So I want to start out by comparing private and public IP addresses to something you're probably already familiar with. Let's say that we are part of a business or an organization, and this organization has their own little phone system. And within that phone system, let's say that everybody has a 4-digit extension. Well, those little 4-digit extensions, they work just fine inside the building. They work just fine if I'm dialing from one of those phones in that building to another phone. But if I instead decide to use my cell phone and I want to call those numbers from my cell phone, that's not going to work because those numbers are private. They're extensions that only make sense inside that little isolated phone system. They're not globally unique, like a real phone number, which is globally unique. That's sort of like a public and private IP address. So let's extend the same concept to computers. So here we can see I have some address ranges, 10.0.0.0 through 10.255.255.255, 172.16.0.0 through 172.31.255.255, and 192.168.0.0 through 192.168.255.255. These are defined as private address ranges. These address ranges are unusable on the internet. They are for private only. And so, yeah, there's certain address ranges that are reserved for private addresses. And if an address falls outside these ranges, it's probably a public IP address on the internet. So these addresses make sense inside of my little private network here. But once I start to leave my little private network, and for example, I need to reach some destination on the internet, well, these addresses don't make sense on the internet. There may be millions of devices that all have these addresses in all their little private networks all over the world. So yeah, these little addresses don't make sense on the internet. They're private IP addresses. And one of the reasons we use private IP addresses is because there's only so many addresses to go around. And there's way more devices out there now than there are usable IP version 4 addresses. There's no way that we could give a public IP address to every single smartphone, every single computer, every smart thermostat, every smart whatever in the world. We have to use private network addresses for those. But most of those devices do need access to the internet. And so if their source address doesn't make any sense on the internet, how do we handle giving these devices internet access? So we'll take a look at how these devices get internet access in just a moment, but I just want to show you one other thing first. Notice when I do an IP config on my computer, look at my IP address, 192.168.0.13. That falls within this private network address range, but I still have internet access. I can still get to the internet. And the thing that typically makes that possible is a router with network address translation. So let's add a router here to our diagram. And I'm going to give this router a public IP address. I'm just going to make it 1.2.3.4 to keep it really simple. But basically, let's assume that this router can perform NAT. It can perform network address translation. And here I'll add a computer to my diagram. Let's say that this guy is 192.168.1.25. So that's the address of one of my computers, and this computer needs access to the internet. Well, the way that this is going to work is it is going to generate a packet outbound headed towards the internet, and the router will capture that, and it'll perform what we call a source network address translation. Basically, it'll say, okay, this is coming from source IP 192.168.1.25. let me remove that source IP and substitute in for it 1.2.3.4. And now, as this traffic flows out to the internet will see the source address is 1.2.3.4. That's an address that the internet can understand. And so when whatever website I'm trying to reach responds back, the response is going to be set to 1.2.3.4, at which point the router will receive that return traffic. It'll pull out that 1.2.3.4 address, and it'll send the response traffic to the original requesting computer. And so that's how NAT works, network address translation. And it basically is there to take a private IP address and translate it to a public IP address. That way, all of the computers on every network don't need to have one of these valuable public IPs. So let's take a few moments to do a brief review and talk a little bit about some of the things we should have learned in this lesson and expand on some of those topics just a little bit. A public IP address. This is going to be an IP address that is globally routable, right? These are IP addresses that make sense on the internet. So think of them kind of like your cell phone number. You're the only person in the world with that cell phone number. Well, a public IP can only be used by one individual at any given time. So you can get public IPs from internet service providers or cloud service providers. They have to be assigned. There's a limited amount of these addresses. And so, for example, let's say that your internet service provider is Spectrum. Well, if your internet service provider is Spectrum, Spectrum has a specific set of addresses that they are allowed to give out. So you could get a public IP from them. And again, these public IPs make sense on the public internet. Oftentimes, they'll be used for routers and firewalls facing the internet. So if your organization has a bunch of computers, and those computers all have private IPs, eventually those computers will connect back to a router that actually has access to the internet. And that device typically will have a public IP, and that'll typically be the only device in your network with a public IP. Now let's compare that with private IPs. Most of the devices on the internet have private IP addresses. The idea here is we give out private IPs to everything to save the public IP address space for things that really need it. And so my computer might have the exact same address as your computer. As long as they're private IPs, it'll still work. Because the private IP only makes sense within your organization. So, for example, think back to the analogy I gave you a few moments ago. Let's say that you work in an office building, and that office building has a bunch of phones that have 4-digit extensions. Well, those 4-digit extensions make sense in your office building. And by the way, the office building next door might have the exact same 4-digit extensions that they use. It'll still work because your building has its phone system and their building has a separate phone system. So those local addresses make sense locally. The private IPs are used within private networks, but do not work on the internet.